Okay, where is turbulence forecasted and at what intensity and durations? Again, I'm double checking that you went through these these AirMets for turbulence, so you can take that information and share that here on question 31. The surface winds exceeding 30 knots not associated with convective activity. The easiest place for you to get this is to go, to the winds and temps on your ad site. Just go to the surface and look at the wind speed. Now, this can be tough to notice, but you're going to want to look for some of these barbs in some of these areas around the fronts. And I don't see maybe but one or two areas that are over 30 knots. I mean, you guys will watch this video and point out that, Dustin, you missed something. What about this one here? Just off the coast here in Louisiana, it looks like you got 25. This one may be 30. I don't see really any others. So I'm going to put over on this question, south and east coastal areas. This is really limited in nature, so we'll just make a note there. That's it. Surface winds are actually one of those things that causes more accidents than just about anything else, weather related. Now, most of them are not fatalities, but for small airplanes, surface winds are accountable for a lot of the accidents and incidents. Okay, that's one way to do it. The other way, if you'd like to, you can go back to that METAR large version, just click on the winds, and that's another way you can get these pretty quick. Question 33 with the mountain waves. I'm also, again, testing your ability. Did you notice anything from the segments? We didn't have any forecast mountain waves that we saw on the segment. If we go over to our turbulence area, there is a graphical turbulence guidance chart that you can kind of look at for potential areas of severe, moderate, extreme areas of turbulence. Okay, now what this maximum does is tell us the turbulence potential from flight level 200 to 450. A lot of jet stream association here. Let's just pick our wind level out at 24,000. Well, it looks like we've got a small area here. If we've got jet stream activity dipping around with this low pressure coming down and around. So that's what we've got in this area. What I would actually be doing as a pilot, since there's no SIGMET, which there often is if the mountain waves are significant, particularly across the Sierras and the Rockies, and you can get some pretty strong mountain wave activity. So I would check the SIGMETs first. The other thing I would do is, if I was particularly in a smaller airplane, I would go check the winds aloft at ridgetop level. Now, this is going to mean 12,000 feet in many of these areas, somewhat higher in some cases. What I don't want to see is winds blowing perpendicular across the Rockies, the Wasatch Range in Utah and Colorado, because we set up that wave action potentially. The other thing I want to look at is stability. If the air is stable, it's much more likely that air is going to go up and come back down and start to form wave action. If it's unstable, it may go up and just keep on going up. What we don't want is real stable air and those winds whipping across there, and we set up these mountain wave conditions. Interestingly enough, I have flown across the Rockies maybe 15,000 feet where you were 2,000 to 3,000 feet above the terrain, and winds were 60 knots directly across and experienced nothing. And I've done it other times where they were 30 but in very stable air, and I got the snot kicked out of me. So I would watch that, okay, as a pilot. I'd be looking at ridgetop wind levels and stability. Well, how are we going to know stability in these areas? There's a couple ways, but one that we could use is back on our standard brief again. On the standard brief, we can go to the area forecast, and they can talk about the air masses in these areas. In the synopsis, it will talk about unstable and stable air and the types of conditions that are prevalent in those areas. So this question, I guess my point is this is going to be tough. You can get the reports from the PIREPs, you can get the forecast from the SIGMET, but you're really, for practical purposes, probably going to have to dig deeper, as particularly as a general aviation pilot. For number 34, forecast or observations of low-level wind shear. If you were to see these, okay, on the Java tools under PIREPs, you're going to see an urgent pilot report, okay? And what it's going to look like is what you have right here, okay? These low-level wind shear, LLWS. I want to see these. I want to see that you can identify these. This airplane, we're going to click on this. This airplane was coming in, it says CRJ2, didn't give us a flight level, but it remarked low level wind shear, lost 15 knots on 1 mile final to runway 2. Okay, well, 1 mile final, we're obviously not very high. This is a concern. This is low level action, so we lost 15 knots on final. There's low level wind shear. We've got another one up here. We'll click on, and it looks like I may have just messed up my Java tools there. I did. I zoomed in on accident. And be patient with me here. Here's another one. This one, plus and minus 15 knots, 300 feet above ground level. This was a 757. Okay, let's. There's actually quite a few of these out today. These are mostly thunderstorm, plus or minus 10 knots. But now you can see how to identify. With the PIREPs, you're going to see an urgent in red, and it'll identify it as LLWS. They flag these for us, okay? So we'll type those in there.